Hello, welcome to STEM School. In this video, we are going to go through Canadian computing competition problems. Let's take a look at our problem here. So problem J3, exactly electrical. Okay. So here we got the problem description. You live in great city, which is composed of integer number streets which run east-west, parallel to the x-axis, and the integer number avenue, which run north-south, parallel to the y-axis. Okay. So the streets and avenues have infinite lengths, and there is a street for every integer y-coordinate and an avenue for every x-coordinate. All intersections are labeled by the integer coordinates. For example, avenue 7 and street minus 3 intersect at 7 minus 3. Okay, you drive a special electric car which uses up 1 unit of electrical charge moving between the adjacent intersections, that is moving either north to south or north or south to the next street, or moving east or west to the next avenue, until battery runs out. At each intersection, your car can turn left, turn right, go straight through, or make U-turn. You may visit the same intersection multiple times on the same trip. Suppose you know your starting intersection, your destination intersection, and the number of the units of electrical charge in your battery. Determine whether you can travel from the starting intersection to destination intersection using the charge available to you in such a way that your battery is empty when you reach your destination. Okay? So here's the input specification. The input consists of 3 lines. The first line contains A followed by B, indicates the starting coordinate. Okay, we got the starting coordinate AB as the first line. So the second line contains C following by D, indicates the destination coordinate CD. Okay, so we got the starting coordinate, we got the destination coordinate, and the third line contains the integer T. In between these values indicates the integer initial number of the units of the electrical charge of your battery. So we got the starting point, we got the destination point, and we got the electrical charge available there. All right, so that's our inputs, and output specification is output Y. If it's possible to move from the starting coordinate to the destination coordinate using exact T unit of the electrical charge. Otherwise, output no. Okay, so that's very specific, and I think this is very clear. So there are some sample data that you can use for testing after you finish your code. Okay, so there's the 3-4, the starting, the destination, and the T number. Okay, the number T there, and the output is yes, should be yes, and there is the explanation to this, right? And there's the sample input, starting point, destination, and the T, and the output is no. Okay, there is the explanation there again here too, right? So it's longer than that you see, so I'm going to stop here for a bit. So this problem, I will say that's very unique and very clear. Before we take a look at the code, which I wrote, we can go to one theory, because the problem is actually to test you about a theory there, so which is called Manhattan distance. So if you know this, that's great. If you don't know this, it's problematic that you need some special logics to calculate whatever you are trying to calculating. But if you know this Manhattan distance, that's pretty easy. All right, so we got x-axis and y-axis, right? So and we got streets and avenues aligned with that, right? So that's basically we are calculating with what is called Manhattan distance between the starting point okay, and the destination. Okay, so there are for this problem, we only need to use the for two-dimensional vectors. Okay, so that's what we're gonna use. And there's the Manhattan distance. Since we are talking about that, I also listed this for here for three-dimensional vectors. It's like this, and general formula for n-dimensional vectors for Manhattan distance. Okay, so the only thing we need to use is this one, the two-dimensional vectors. All right. So now with the answer or the tip here, we can take a look quickly about the code. It's very straightforward. All right, so we got the input A, B, C, D, okay, starting coordinates, destination coordinates, and the battery, right? So calculate the Manhattan distance. Okay, so if Manhattan distance is smaller than or equal than T, and T minus Manhattan distance remainder 2 equals 0, then print yes, it's possible, otherwise print no. All right, so the answer is quite straightforward based on our knowledge of Manhattan distance. Otherwise, I would say the problem is will be pretty difficult if you don't know about this. So again, here's the problem description. I'm just going to stop here for you to read this again and think of it, how you're gonna solve it. Okay, and here is the code, which is just few lines. That's everything for today's lesson. Please click like if you like this video and subscribe my channel. Thank you.